Then the basis unit assembly of atoms or molecules which are identified with respect to the position of lattice points. The repetition of basis correct periodicity in all directions. In the crystal structure, so lattice point plus base is equal to crystal. So lattice by denoted as the position of atoms or molecules plus base is equal to crystal structure. So the diagram shows that the crystal structure, lattice point and base is. So finally, unit cell, fundamental building block in 3 dimensions. So repeating it one dimensions in various directions gives crystal structure. Then the next important topic is lattice parameters. So in crystallographic axis x comma y comma z, then the crystal length or axial length denoted as x comma y comma z direction or a comma b comma c. It is called interaxial length and interaxial angles. So alpha the angle between a and b, then beta the angle between p and c, then gamma the angle between c and a. So primitive cell, the unit cell consists of only one lattice point, that is only one full atom. So primitive, there are 3 different types of crystal structure. The first one is primitive, so lattice points at corner only, then body centered lattice point corner and body centered atom, then face and a cubic, base and a cubic. If a unit cell consists of more than one lattice point or one atom, that is called non-primitive cell. So the first line we are knowing about unit cell consists of only one lattice point. The last one, the unit cell consists of more than one lattice point. That is difference between primitive and non-primitive cell. So examples for primitive cell, simple cubic. So basically simple cubic structure having only one lattice point and only one atom. So lattice points at corner only. Example for primitive cell, that is called simple cubic. The example for non-primitive cell, BCC and FCC. So lattice points more than corner. So the different types of crystal system. The first one is cubic. The axial length of cubic A equal to B equal to C. So we are knowing A equal to axial length of x-axis, B equal to axial length of y-axis, and C equal to axial length of z-axis. So in cubic system, A equal to B equal to C. So all the axes are equal. Then axis length x comma y comma z. Then alpha beta comma are equal to 90 degree in cubic system. Then second one is tetragonal. A equal to B but not equal to C. So that x comma y equal to same but not equal to height. So alpha beta comma equal to 90 degree. Then next one is orthorhombic, that is A not equal to B not equal to C. So all the axial length are totally different. So axial length of x comma y, x not equal to y not equal to z. Then the axial angle alpha beta comma are equal and also equal to 90 degree. Then the fourth system, rhombohedral, the axial length A equal to B equal to C, and alpha beta comma are equal but not equal to 90 degree. Then the hexagonal, axial length A equal to B but not equal to C, alpha beta equal to 90 degree, then comma equal to 120 degree. Then the monoclinic, A not equal to B not equal to C, then alpha gamma equal to 90 degree but not equal to beta, that is beta not equal to 90 degree. Then finally seventh system, triclinic, all are not equal. So A not equal to B not equal to C, and also alpha not equal to beta not equal to gamma not equal to 90 degree. So these all are the different types of crystal systems. Then the table shows that the crystal system, axial length and interaxial angle, the number of lattice points in the system, number of possible types in 7 systems. For example, in cubic there are 3 types possible. First one is simple cubic, second body centered cubic, third face centered cubic. Then tetragonal only 2 types, then orthorhombic 4 types, monoclinic 2, triclinic 1, tetragonal 1, then hexagonal. Finally we are having 7 system but 14 possible types are available. So finally the answer is Pravis lattice value equal to 14. So the diagram shows that the 14 different types of crystal system. For example, cubic simple, face and body centered, but tetragonal simple and body centered tetragonal. In hexagonal only simple system is available. Then orthorhombic, monoclinic, then finally triclinic. And the previous lattices of 7 different types of systems. So P equal to primitive, that is atoms only at corner point, then bodies ended, face and base ended.